All right, let's try a video solution here from number 10. It's question 7. It says here, and remember this chapter is about our rotational mechanics, our last one and maybe the hardest one on mechanics. It says here, a gyroscope slows from an initial rate of 32 radians per second at a rate of 0.7 radians per second squared. All right, so we have something slowing down. How long does it take to come to rest? Well, my hint for you guys was to think about these rotational problems, especially these on kinematics, a lot like you would do a translational problem. And this one sounds like a good problem involving kinematics equation number 1. Because first of all, they gave us a constant acceleration. Okay, that's good. Then second of all, they are asking a question about one of the variables, in this case time, how long does it take? They give us some other parameters, but they're always one that they're uninterested in. And when I say that, one that's missing. They don't talk about it, they're not asking for it. And in this case, I would say right now it's final speed. And that was the magical one for, I'm sorry, not final speed, distance traveled. Distance traveled is the piece that's missing. And that's a perfect recipe for kinematics equation number 1. Because you see, when it says how long does it take to come to rest, they've just said that the final speed is 0. And they made it very clear that the initial speed is 32 radians per second. The only thing that might make this first step a little challenging is the phrase when it says it is slowing down. So they don't give us a negative in the question, but they say it in words by saying it slows down at this rate. So they're saying the angular acceleration is 0.7 radians per second squared. So that now, when you solve for time, you'll move 32 to the other side, which would make it negative. Then you divide by a negative 0.7. The two negatives would cancel off, and you should end up with about 45.7 seconds. How much time does it take? Now, part B does say then how many revolutions does it make? And so this is, asking how far did it travel. And at this point, since we have time, we could do kinematics equation number 2. We, for that matter, could do kinematics equation number 3. We could also do kinematics equation number 4, probably even number 5, but I'll stop there. I think I listed 1, 2, and 3. So why don't I stay away from this one, although this would be a real easy one to do. Put initial and final speed, divide by 2, and multiply by time. But since I didn't talk about that one, and also let's stay away, I guess, from number 2, only because it involves time, and so if I got A wrong, then I would get B wrong. So I'm kind of leaning towards solving B this way. This is the way I would solve it had it been the first question, because if it was the first question, I wouldn't know time, and they're not asking for time, and this is the equation that you should use when you have that scenario, that you don't have the time, and they're not asking for it, and so here's an equation that doesn't have time involved. So I'll go ahead and use this. And so final speed squared is 0. Initial speed is the 32 radians per second. Again, being a little careful with the phrase slowing down at a rate of 0.7 radians per second squared. I can then get this angle. All right, so again, moving the 32 squared to the other side, I guess that's a 1,024, and it would be a negative. But I'm going to divide by a negative, so it'll come out positive. So I'll just kind of avoid the two negatives, make my steps a little easier. But it looks like the angle is 731.4. And if you're looking carefully here, it's in radians, whereas the question says how many revolutions is this? All right, so my change in angle, this 731.4 radians, needs to be converted from radians to revolutions. And this is our standard unit conversion that I warned you about in chapter 1. It's kind of easy to convert from things we've heard before, but maybe and done before, but a little harder for ones we haven't seen before. And that's a skill to develop here, because at this point in the semester, we're going to start working with and talking about units that are new to you, like a joule and a watt and all kinds of other units coming up. And probably you haven't done too much between radians and revolution. But like any thinking, you want to put the radians on the bottom, because that'll cancel off, and then revolutions would go on top. And the key is you're multiplying by a magical number 1. A magical number 1 means what's on the top is the same as on the bottom. And so 1 revolution is 2 pi radians. And so a full circle around 1 revolution is also 2 pi radians. So this is a number 1. So you're not really changing anything other than converting its unit. All right, so taking that number and dividing it by both a 2 and a pi give me 116.4 revolutions. So that's how many times it would go around. All right, good one on kinematics here.